Hello and welcome to Haybridge Maths Department, Year 2 Pure, and we're looking at Chapter 5, Radians, and we're looking at, to start off with today, arc length. Now, this is an application of radians. It's a topic that you will have covered at GCSE, but you'll see that when we measure our angles in radians, as we have been doing, the formula for arc length is actually easier. So this is one of the rare occasions when at A level, the question or the topic is easier than at GCSE. So we're going to have a look at the formula for that and some very simple applications of that before in the next video going on to some more complicated versions of it. But before we do that, I thought today we'd start you off with a starter. Could you have a go at sketching the graph of y equals sine 2x between 0 and 2 pi? So pause the video, have a go at sketching that, and then I will show you the answer to that in, well, if you pause it whenever you're done. Okay, so here's what the video looks like. Okay, so notice that it intercepts the x-axis at pi over 2, pi, 3 pi over 2, and 2 pi. As it does in degrees, it goes between 1 and -1. But the main thing to note is where it cuts that x-axis, but it's at pi over 2, pi, 3 pi over and 3 pi over 2 and 2 pi, because of course it's a transformation of the graph y equals sine x. It is a enlargement, bizarrely, but it's an enlargement scale factor of a half in the x direction. So it is enlargement scale factor a half in the x direction. Okay, let's get back onto what today is about, and it is about the formula for arc length when we measure in radians. So here you go. Now, arc length, if you remember from GCSE, is this length here. It's this length here. And so it's the part of a circle. An arc is a part of a circumference. I should be a bit more specific. It's a part of a circle. And the way that we do this, the way that we work out the length of it is when we're in radians, all we need to do is take the radius and multiply it by the angle if it has been measured in radians. So it's just r theta. What could be more simple than that? And it's a very straightforward formula. Okay, so make a note of that, and then let's have a look at a very, very simple example here. So here we have L equals r theta, and we're just going to find out L when r equals 4 and theta equals 0.5. So if we have L equals r theta, then all we do is 4 times 0.5, which is 2. A very badly written 2, but 2 nonetheless. Okay, make a note of that in your notes, and then have a go at this question here. Hopefully equally straightforward. So press pause now. Have a go at this question now and press pause, and I will go through it then. So L equals r theta, r equals 3, theta equals 0.9, so L equals 2.7 centimeters, kilometers, light years, millimeters, nanometers, whatever the units they've given you. Theta, of course, does matter, but it's in radians. But I guess R could be whatever unit that you want it to be. Okay, so that's really, I hope, straightforward. I'm going to do another example and then get you doing another example where we have to do a slight rearrangement. But compared to some of the stuff that you've done already, this, I hope, is a walk in the park. Okay, so on this one, we've been given the length of the arc, it's 12, the radius, which is 4, and we need to work out theta. So if we go L equals R theta, so 12 equals 4 theta, and then theta equals 3. It is as straightforward as that. Okay, you guys have a go at this next example. Okay, you have a go at this example. I press pause now, and then I will do it in 2 ticks of a cat's tail. Okay, so we have L equals R theta, and we have 18 equals 3R, and therefore R equals 6. And we're done. It is as simple as that. In the next video, I'm going to go through some more contextual questions, but really, they aren't too bad. It should be quite straightforward, even when we put this into context. But for now, thank you very much for watching, and I will see you next time. Goodbye.